Okay, so this is our pyruvate malate cycle video. This should be a super quick video because we've mentioned this before. If you think back to not our previous video, but the one right before it, when we were talking about lipid synthesis, we saw our citric acid leaving the Krebs cycle, leaving the mitochondria, going out into the cytoplasm to become acetyl-CoA and to then begin the process of fatty acid synthesis. And we also saw that a byproduct of that was oxaloacetate, which got turned into malate, and then we didn't really discuss how that malate then entered back into the mitochondria and into the Krebs cycle. We talked a bit about the malate aspartate shuttle and all that, how that tied that into what we've talked about before, but we haven't looked at exactly precisely the pyruvate malate cycle. So we just need to look at how we're taking essentially the acetyl-CoA that we made from citrate and creating also oxaloacetate and moving that back in so that it can re-enter into the Krebs cycle. So instead of focusing on going off into fatty acid synthesis, we're also talking about getting that back into the mitochondria and going back into the Krebs cycle. So here are the steps. So the first step, step number 1, we have an enzyme called pyruvate carboxylase. This will act on pyruvate, so we know where pyruvate came from. It came from glycolysis, and it forms oxaloacetate. So this is happening in a variety of places. It's just another source of oxaloacetate. We've seen oxaloacetate as coming out of the Krebs cycle. We've seen it as coming out of acetyl-CoA. We've seen it as coming out of aspartate. So we've seen oxaloacetate being able to be made by a lot of different other molecules. But here is another way. By taking pyruvate, using pyruvate carboxylate, and now we have oxaloacetate. Now, meanwhile, we're going to have another pyruvate molecule acted on by pyruvate dehydrogenase. We know that part. That is the part that we use if we're going from glycolysis into the Krebs cycle. It's how we get acetyl-CoA out of pyruvate. So now, through these two processes happening at the same time, we have oxaloacetate and we have acetyl-CoA. Okay, so we should pretty much know where we're going with this. Oxaloacetate, the end of the Krebs cycle, acetyl-CoA going into the Krebs cycle, together they make citrate. So that's the first step in our Krebs cycle. Of course, we could run the Krebs cycle, get energy, but we're talking about fatty acid stuff, so we're not running the Krebs cycle so much right now. We are inhibiting the Krebs cycle, slowing it down, building up our citrate. So we know that the citrate then is going to go into the cytoplasm because it's not able to continue on through the Krebs cycle. It's going to be carried into the cytoplasm by those citrate tricarboxylate carriers that we mentioned. Then we use our ATP citrate lyase. Remember that enzyme? ATP should be written there. The ATP citrate lyase breaks down our citrate into acetyl-CoA. That goes on to fatty acid synthesis. And then we've already seen having oxaloacetate as kind of a byproduct of that. So we talked enough about fatty acid synthesis before, and now we're just going to focus on our oxaloacetate. So the process that happens to oxaloacetate is that an enzyme called malate dehydrogenase is going to reduce the oxaloacetate, so adding an electron or hydrogen to the oxaloacetate, and that gives us malate. Okay, so we've seen oxaloacetate turning into malate before when we did the malate aspartate shuttle. We saw that, and the reverse reaction too. But here we are going to take that malate, and instead of using it as a shuttle, we're going to use something called a malic enzyme, and that makes pyruvate. So we're kind of right back to where we started. Full circle. We did all this stuff, and then, okay, we have pyruvate again. And just think of it as a switching mechanism. up here, we're in the fed state. We're wanting to do fatty acid synthesis. Once we get down here, maybe we're not in the fed state anymore. Maybe we want to start doing energy again. So this is a way to go, okay, we can start making energy, start switching back over to energy, or to just not bypass the energy production completely, even if we are in the fed state doing fatty acid synthesis. You still need energy, just maybe less because you have some extra, but you still want to do it. So we can still continue to get our source of pyruvate. Okay, so this slide here, this is a familiar slide, from our last video, or 2 videos ago, I should say. So remember that we looked at it as, where's our glucose? Here's glucose. There's glycolysis up here, so the familiar parts again, glycolysis going into the Krebs cycle, citric acid cycle, whatever you want to call it. There's a pentose phosphate pathway, getting the NADP. With our Krebs cycle, as we go from pyruvate into acetyl-CoA, going into citrate, but we inhibited our Krebs cycle after citrate, so the citrate builds up, we get acetyl-CoA, we get into fatty acid synthesis. Okay, we know all of that. We have seen the oxaloacetate coming out of the citrate as well. Acetyl-CoA and oxaloacetate are the products here. This would be that citrate, the ATP citrate lyase right there, that's the enzyme. And now we'll just focus on the oxaloacetate. So we have malate, so we transformed our oxaloacetate into malate. Then the malate enzyme transforms it into pyruvate again. So we went from pyruvate to acetyl-CoA to citrate, through to oxaloacetate to malate. Now we're back to pyruvate again. That can go, through pyruvate dehydrogenase into acetyl-CoA into citrate. It could go right back out again and make more fatty acids this way, or we could run it through the Krebs cycle. Just how it's all tied together right there. It's all really cool how interconnected that is. So that's it for the pyruvate malate cycle.